So here's an example where an instructor wants to look at the relationship between the number of absences a student has in a stats course and their final grade in that course. The idea is probably that the more absences a student has, the lower their final grade would be. This relationship where one thing increases leading to another thing decreasing, that's called a negative linear relationship. Hoping for a negative R, remember R can only be between -1 and +1. Closer to those values means a relationship is there, and closer to 0 means it seems there's no relationship. Now we did learn the formula, but we did also start learning how to input variables into our calculator. This is a 2-variable data set. We have an X and a Y. Really, this is from one person. We could write this as 6,82, kind of how we've seen points before. In fact, we could even graph this on an XY axis to kind of see the relationship. If we let X go this way and Y go this way, that means that this is the number of absences and this is the grade, final grade over here. And the absences, let's see, we go from 2 to 15, so maybe I'll go, 2, 4, 6, 8, 10, 12, 14, 16. And the final grade starts at 43 and goes up to 90. So I'm going to do a little break here. It says I'm skipping some numbers. I'm going to start at 40. Go 50, 60, 70, 80, 90. I don't go above 90. And I could plot these points. So I already showed you the first one, 682. So 6 on the x-axis over here. And then 82 on the y-axis, and that gives us a point about, So it's about there, 682. The next point, 2,86, has an x value of 2, a y value of 86. That's something up here. Then 1543 would be maybe over here somewhere. 974 would be about here. 1258 would be somewhere here. 590 would be all the way up here. And 878, something about here. So it does seem that there is a relationship as the absences increases, goes that way, the grade seems to decrease. I'm thinking a negative linear relationship. And I'm going to put that in question because I don't quite know yet. To know for sure, I need to find the correlation coefficient R, which has that big formula, but I'm just going to use my calculator. Remember, I go into my stat menu, I have to shift, and I go into stat, and I have to make sure that my stat mode is set to 2-variable stats. So maybe it's helpful to exit stat to clear out your calculator, go back into the stat menu, and select 2var for 2-variable statistics. Then you're going to hit the data button, and it should pop up x1. It's asking for this first x value. So I'm going to put 6, and I'm going to select my down arrow. It should pop up y1, and that means the corresponding first y value. I'm going to put 82. If I hit down again, it should pop up and say x2. That means it's looking for the second x value. So I'm going to put 2. If I press down again, it should say y2. That's my second y value, 86. Doing this again, x3, that's 15, y3, 43. x4 is 9, y4, 74. x5 is 12, y5, 58. x6 is 5, y6 is 90. x7 is 8, y7 is 78. Then from there, I can hit stat var, and it will run stats on my variables. So when you hit that button, it will say calc for just a second, and then that screen goes away, and it gives us some things to look at. Okay, so it gives us, let's erase really quick. Let's erase some of this stuff. One of the things it gives me is n, which it says is 7. It also gives me x bar, which I don't really need for the correlation coefficient. Just to remind us how that formula looks, r equals n times the sum of xy minus the sum of x times the sum of y, all divided by big, beautiful square root with 2 bracket sets. The first one is n times the sum of x squared minus the sum of the x's squared. That's the first bracket set. The next bracket set, n times the sum of the y squareds minus the sum of the y's squared. Okay, the calculator will give us several of these little pieces. If I scroll to the right far enough, I will see the button, or the symbol sum of x, which it says is 57. If I go right again, it'll say the sum of x squared, which is 579. Going to the right again, I see sum of y, which is 511. Again, going to the right, I see sum of y squared, which is 38,993. Going to the right again, it gives me another one, the sum of xy, which is 3745. And all of that's irrelevant because it gives me the actual r value. If you keep going all the way to the right, it says r equals negative 0.944215171. So if you plugged all of these values into this beautiful formula, you should get this correlation coefficient. We tend to round it to 3 decimal places, so my final answer, I will let that be negative 0.944, which is what I expected. First of all, it's negative, and secondly, it is a value very close to negative 1. The stronger it is, the closer it will be to either 1 or negative 1. The weaker the relationship, the closer it will be to 0. So since this is very close to negative 1, I believe these variables have a very strong negative linear relationship, which makes sense. As the number of absences increases, somebody's grade is most likely going to decrease.